In problem number 2, we're given a table of values and we're asked to write two possible equations, sine or cosine, for each given table. So I'll go ahead and do one potential equation for sine and one for cosine, but keep in mind that for both of these there's many possible answers, so the answer you come up with may not be exactly the same as mine. So it is possible to do these without graphing them, but if you have trouble doing these without graphing them, I would suggest plotting the points and then determining the equation. So in this case, negative pi over 2, 1, 0, 1.5, pi over 2, 1, pi, 0.5, 3 pi over 2, 1. And I'm going to refer back to the sine and cosine graphs that I graphed on number 1 up here. So compared to this is more similar, I would say, to the cosine graph, since the highest point of the graph is at 0 and then it's shifted up to 1.5. But the amplitude is only 1/2 on this graph, as opposed to y equals cosine x, which has an amplitude of 1. So I'm going to use an amplitude of 0.5. I'm going to use cosine of x. This didn't get shifted right or left, so I'm going to do cosine of x. And then after the amplitude is reduced by 1/2, this original cosine graph would have been down here. So from here, it's gotten shifted up by 1 unit, so plus 1. Now if I look at the same graph and I want to write another equation, you could write another cosine equation. I'm going to write a sine equation just to show what that could look like. So compared to the original y equals sine x graph, we could say that, again, this graph has a smaller amplitude, so 1/2 is the amplitude. And then sine, this graph has been shifted left by pi over 2 from this graph, so it'll be x plus pi over 2. And after being shifted left by pi over 2, this graph has also moved up by 1 unit. Let's look at part B. We have another table of values here, 0, 2, pi over 2, 0, pi 2, 3 pi over 2, 4. So that's going to be way off the graph here. And then 2 pi is back at 2. So I have this curve. So I'll do again an example of cosine and an example of sine. So if this was a cosine graph, the top of this cosine curve is now shifted over to here. The top of the curve is here. So I'm going to consider that the cosine graph has been shifted right by 3 pi over 2 units. The amplitude of this graph is also twice as big as the amplitude of this cosine graph. So I'm going to use an amplitude of 2. Cosine, this graph was shifted right by 3 pi over 2 units. So x minus 3 pi over 2. So if this has double the amplitude and is shifted over by 3 pi over 2, the top of the graph would end up here. But here the top of the graph is 2 units higher, so I'm going to do plus 2 to take care of that. If we look at the same graph and we think of it as a sine graph, this part of the sine wave has been shifted to here. So right by pi and up by 2. And the amplitude has doubled again. So 2 sine x minus pi would give us right by pi units and up by 2 in the y direction.